Hello my friend, happy to see you here. Today we have great and relaxing algebra question. We know the difference of squares a square minus b square equal to 6 and the product a times b equal to 4. We need to solve this question for a plus b. So if you have your solution, your answer, your approach, you can also write it in the comments below and then we will check our answers. Okay, so we need to solve it for a plus b. And the first way to do this is to raise this first equation to the second power. So let's do it. This is our first way. How can we solve it? So we raise a square minus b square, so we raise this to the second power. On our left side we raise to the second power, and we raise of course our 6 to the second power. So we square our both sides. What are we going to do next? Of course we need to simplify this real quick. This is our classic school identity. So a squared to the power to a to the power 4 plus b to the power 4 and minus a product 2 times a square times b square and equal to 6 square equal to 36. Right now this product right here, let's write on the right side. Okay, so we need to add both sides to this. So right here we'll have with the positive sign. Okay, so we have a to the power 4 plus b to the power 4 and equal to 36 plus 2 times a square times b square. Right now there is extremely great property because this one we can write as, I'm going to write it right here, so we can write it as, in terms of a property, this expression, this our property, we can write as a times b to the power 2. We can write it as a to the power 4 plus b to the power 4 equal to 36 plus 2 times a times b to the power 2. Okay, it works in both ways, so we can write this one or this one, doesn't matter, because we will have the same thing. Right now, a product a times b equal to, we have it right here, equal to 4. This product equal to 4, so we can solve for a to the power 4 plus b to the power 4 equal to 36 plus 2 times 4 square equal to 16, so we have 16 plus times 2, we have 32, so plus 32. So as a result, our a to the power 4 plus b to the power 4 equal to 68. Yeah, we have 68, and this is extremely important identity for us. Right now I'm gonna write really interesting and great identity, another identity. So this is not from here, this is our school identity. I really hope you understand what I mean. I want to raise a square plus b square, I want to raise to the second power. Okay, I'm gonna square this. What do we have as a result? As a result, we have a to the power 4 plus b to the power 4 and plus 2a square times b square. Okay, these are a school identity, so we don't have like a and b, we have a square and b square. So I hope you understand it. And right now let's look closely. What do we know from here? So a to the power 4 plus b to the power 4, right here we know that this is equal to 68. Okay, we have 68. What about this product? We know it because this is our, I'm gonna explain it right here, the same logic. This is equal to a times b to the power 2, and this is equal to 2 times a times b equal to 4 from the beginning. We have it right here. So 4 square, so 2 times 4 square. So as a result, we can solve it for a square plus b square to the power 2. So let's write it. So a square plus b square to the power 2 equal to 68 plus 4 square, 16 times 2, 32, 68 plus 32 equal to 100. So this is extremely great because right now we have a really great equation and we can solve it, we can simplify it. First of all, we need to apply square root on both sides. As a result, we have a square plus b square raised to the power 2 equal to plus minus square root of 100, plus minus square root of 100. And right now let's look closely. Right here we can easily cancel this square root with these two. So as a result we have a sum a square plus b square, a square plus b square equal to square root of 100. This is our table case, so we have plus minus 10. And one really important moment right here, because Because exactly in this case, we have on the left side, we have the sum of two squares. And a sum of two squares doesn't matter if we're talking about negative a and b or negative, positive, positive, negative. Doesn't matter what combinations we consider right here. There is no way this sum of two squares is equal to negative 10. Okay, so we need to reject, so negative 10 minus 10 we reject. So we reject this, so rejected. So we're talking about a classic a square plus b square equal to 10. Okay, this is not our answer because we need to solve it for a plus b. So but a plus b, we don't know exactly right here, so we need to solve it for a plus b. So how can we do that? First of all, let's forget a little bit about this solution and let's remember really important identity. Maybe this is the classic identity, a plus b to the power 2. This is a classic school identity, equal to a square plus b square, a square plus b square, and plus 2ab. This is a classic school identity, maybe the most popular identity, everyone should know about it. And right now, let's look closely what do we know from here. Right here we have a plus b, so expression that we need to find. We have it to the second power, we square it, but doesn't matter, we will solve it. On the right side, a square plus b square, we know it, this is equal to 10, this is a sum of two squares. And to AB equal to 4. We had it almost 2 times right here, so AB equal to 4, AB equal to 4. So as a result, we have right here we have 4. So let's plug in everything from here. So our a plus b to the second power equal to, so sum of two squares, we have 10 plus 2 times a4 equal to 8. So we are talking about 18. So a plus b square equal to 18. And our final step, let's solve it for a plus b. Okay, so let's do it. So we have square root of a plus b square equal to plus minus square root of 18. Okay, right now let's simplify this. So this one and this one, not like simplify, we can cancel this because we, in terms of like school identity, in terms of property, we have a plus b equal to plus minus square root of 18. And right here, of course, we can consider negative value because we don't have squares. Right here we have important thing because we have a sum of two squares, and doesn't matter if we're talking about two negative a and b. If we raise to the second power, we have a positive value. So right here we need to reject negative because we're talking about squares. If we had cubes right here, then we would like leave it like that without any changes because cubes can be negative. Squares, positive, so we reject negative value, but in this case we need to keep this negative sign because a plus b, a can be positive, a can be negative. So let's simplify this real quick because square root of 18 we can simplify it. We have a plus b equal to plus minus square root of, the basic way is like or 6 times 3 or 9 times 2, but 9 times 2 is even better for us because we can split it like square root of 9, our table case, times square root of 2. So as a result of our final answer, plus minus 3 square root of 2. So let's write our final answer. Our answer, so a plus b equal to plus minus 3 square root of 3 square root. We have like two branches, positive and a negative branch. So it was my solution to this question. I really hope you understand it. I really hope you learned something new. And maybe the last thing I want to say, because maybe a lot of students don't understand why I reject negative. So just a few tips from here, because when we have a square plus b square, if you're talking about a positive a and b, it works absolutely perfectly. For example, a and b equal to 2. So we have 2 square plus 2 square. This is 100% is positive. So I don't want to evaluate it. I don't want to simplify it. And a lot of students might be thinking, but when a and b is negative, so let's talk about it. Minus 2 square plus, for example, minus 2 square. Doesn't matter what sign do we have right here. When we raise to the second power, it always be positive. So as a result, we have a positive value. So there is no way this expression is negative. Maybe this expression equal to 0, but in our case, we're not talking about 0 because we're talking about only positive or negative. In our case, this is 100% positive expression. Of course, there's like the third branch. Maybe this is our like a complex roots, but we're talking about like a school thing. This is our school question. So, and I don't want to talk a lot about complex numbers. I'm talking about a classic system of two equations. So that's why we eliminate, we reject our complex plane. From here, we have a classic question for school. Sometimes I see this type of question on entrance examination because this is not easy question, because when we're talking about a square and b square right here, so this is not a classic system of equation from school. Sometimes a lot of students have problems with this type of question, so that's why I think that this is extremely great question for everyone, and even for teachers. Maybe they wanna test their kids, their in class, and they want to practice this type of question. So that's why I think that this is great question for everyone. Okay, so it was my solution to this question. I really hope you understand it. I really hope you learned something new, but definitely don't feel bad if you got this wrong. If you need help with any of these classes, I have a lot of questions on my YouTube channel, a lot of different challenges, and of course, if you have your solution your way, how could you solve this type of question? Because this is my way. There are a lot of different solutions right here, a lot of different combinations, a lot of different way how can we solve it. So I will be really excited if you write your solution your way. How can you solve this type of question? This is my way. Maybe you have your way. It will be really interesting to read about it in the comments below, because maybe a lot of students here and they, for example, they don't understand my solution and they see your way maybe more convenient, more faster. It will be really great for everyone. Yeah. So thank you everyone for your time. Take care of yourself. Have a great day. See you in the next videos.